Microsoft has been cooking up some seriously impressive and potentially unsettling AI tech. Their latest project, codenamed Val-E2, is a text-to-speech program so realistic it's spooking even Microsoft. While whispers of this groundbreaking tool have been circulating, Microsoft has chosen to keep it under wraps. But what exactly makes Volley 2 so scary, and why is it being shelved for now? Let's find out. Microsoft's new AI speech tool, Valley 2, represents Microsoft's latest achievement in neural codec language models, particularly in the realm of zero-shot text-to-speech synthesis. This model signifies a groundbreaking achievement by reaching human parity for the first time, meaning its ability to generate speech from text now matches the naturalness and fluency of human speech. It is a significant leap forward in making text-to-speech systems more effective and natural for a wide range of applications, from virtual assistants and automated customer service to content creation and accessibility tools. Valley 2 builds on the advancements of its predecessor, Valley, by introducing two major enhancements: repetition-aware sampling and grouped code modeling. These innovations are designed to address specific limitations of earlier models and improve overall performance. Repetition-aware sampling is one of the key advancements in Valley 2. In text-to-speech synthesis, repetition in speech can be a challenge, particularly when generating long or complex sentences. Traditional models sometimes struggle with maintaining natural rhythm and avoiding repetitive patterns that make the speech sound unnatural or robotic. Repetition-aware sampling addresses this issue by focusing on the detection and management of repetitive elements in the generated speech. It refines the nucleus sampling process, which is a method used to generate text by selecting tokens based on their probabilities. In traditional nucleus sampling, the model can sometimes produce repetitive sequences of tokens, which affects the naturalness and fluidity of the speech. However, repetition-aware takes token repetition into account during the decoding process. This enhancement helps to stabilize the decoding, ensuring that the generated speech does not get stuck in repetitive loops. It also prevents the infinite loop problem seen in Val-E, where the model might continue generating the same or similar tokens endlessly. By managing repetition more effectively, repetition-aware sampling improves coherence and variety of the synthesized speech, thus improving the overall quality and fluency of the output. Grouped code modeling is another significant enhancement in Val-E 2. This approach involves grouping similar types of linguistic or phonetic codes together. It organizes the codec codes into specific groups, which helps to manage and shorten the sequence length of the generated text. In text-to-speech synthesis, dealing with long sequences can be challenging due to the increased computational load and potential for degraded performance. Grouped code modeling addresses these challenges by grouping related codec codes together, which simplifies the processing of lengthy sequences. This approach not only speeds up the inference process, but also enhances the model's ability to handle long sequences more efficiently. By organizing and grouping these codes, Valley 2 can better understand and generate nuanced aspects of human speech, such as intonation and emotion. This grouping not only enhances the model's ability to generate diverse and contextually appropriate speech, but also improves its performance in various linguistic contexts. These advancements make Valley 2 a powerful and reliable tool for generating natural-sounding, human-like speech. Valley 2 capabilities. Microsoft's experiments with Valley 2, conducted using the LibreSpeech and VCTK datasets, have demonstrated that this advanced neural codec language model significantly outperforms previous zero-shot text-to-speech systems in several critical areas. One of the key strengths of Valley 2 is its robustness in handling diverse and challenging speech scenarios. The model excels in generating stable and consistent speech outputs, even when dealing with complex sentence structures or repetitive phrases. This robustness is crucial for ensuring that the synthesized speech remains clear and intelligible across various contexts and use cases. Microsoft's experiments show that Valley 2 can maintain high-quality speech synthesis without succumbing to common issues like distortion or unnatural repetition, which often plague earlier TTS systems. Valley 2's ability to produce speech that sounds natural and fluid is another significant advancement. Achieving a natural-sounding voice is essential for user acceptance, and practical application is attributed to its sophisticated training methods and the innovative use of repetition-aware sampling and grouped code modeling. These techniques help the model generate speech with a more human-like intonation and rhythm, making it more pleasant and engaging for listeners. The experiments conducted on the LibreSpeech and VCTK datasets confirm that VAL-E2's speech synthesis closely mimics the way humans speak, setting a new standard for naturalness in TTS systems. Another area where VAL-E2 excels is in maintaining speaker similarity. This is particularly important for applications requiring personalized or consistent voice outputs, such as virtual assistants or automated narration services. VAL-E2 can accurately replicate the vocal characteristics of a given speaker, even with minimal input data. The model's ability to perform zero-shot speech synthesis, where it generates speech using a brief sample from an unseen speaker, demonstrates its proficiency in capturing and reproducing unique vocal traits. The experiments showed that VAL-E2 can produce speech that not only sounds natural, but also closely matches the original speaker's voice, enhancing the overall user experience. The benchmarks used in Microsoft's experiments, namely the LibreSpeech and VCTK datasets, are well respected in the field and provide a rigorous test of the model's capabilities. By surpassing previous zero-shot TTS systems on these benchmarks, VAL-E2 has set a new benchmark for what can be achieved with AI-generated speech. VAL-E2 can consistently synthesize high-quality speech even for sentences that are traditionally challenging due to their complexity or repetitive phrases. This achievement sets VAL-E2 apart as a robust and reliable tool for generating natural, fluent speech from text, addressing common issues faced by previous models. A standout feature of VAL-E2 is its ability to synthesize personalized speech even when working with difficult text from sources like LLV. LLV, known for its intricate and often complex text, poses a significant challenge for many TTS systems. However, VAL-E2 excels in this area, leveraging speaker prompts sampled from the LibreSpeech dataset to produce personalized, high-fidelity speech. This capability demonstrates the model's advanced understanding and reproduction of nuanced speech patterns, ensuring that even the most challenging texts are rendered naturally and accurately. Furthermore, VAL-E2 can perform zero-shot speech continuation, a task that involves continuing speech from a brief initial audio sample. Using just a 3-second prefix as the speaker prompt, the model can seamlessly continue the speech, maintaining the speaker's characteristics and ensuring a smooth transition. This ability to perform zero-shot continuation highlights the model's capacity to understand and replicate the unique attributes of a speaker's voice from minimal input. In addition to speech continuation, VAL-E2 excels in speech synthesis, using a reference utterance from an unseen speaker as the prompt. This means that the model can generate speech that matches the vocal characteristics of an unfamiliar speaker, using only a brief sample of their voice. This functionality allows for the creation of personalized speech without extensive training data. VAL-E2's capability extends to synthesizing speech from various lengths of speaker prompts. Whether using a 3-second, 5-second, or 10-second sample, the model can produce accurate and natural-sounding speech. This flexibility is crucial for adapting to different contexts and requirements, providing users with the ability to generate high-quality speech from varying amounts of input data. The audio and transcriptions for these tasks are sampled from the VCTK dataset, ensuring a diverse range of speech patterns and accents are represented and accurately synthesized. Ethical consideration. Despite VAL-E2's remarkable capabilities, Microsoft has wisely chosen to keep VAL-E2 under wraps, refraining from public release. This decision shows the powerful and potentially disruptive nature of this technology. The audio samples provided by the developers of VAL-E2 illustrate just how advanced the model has become. In these samples, there are columns showcasing the original voice sample of a speaker, followed by columns where VAL-E and VAL-E2 attempt to synthesize sentences in the mimicked voice. The results are astoundingly accurate, with VAL-E2 producing speech that is nearly indistinguishable from the original speaker's voice. The impressive quality of VAL-E2's output is both exciting and a bit unnerving. The ability to mimic human voices so convincingly raises various ethical and security concerns. Microsoft acknowledges the potential risks associated with DALL-E 2, particularly regarding voices that closely resemble real individuals, raises concerns about spoofing voice identification systems and impersonating specific speakers and other deceptive practices that could exploit the technology. Given these risks, the company has stated that there are currently no plans to incorporate DALL-E 2 into a product or to expand access to the public. According to Microsoft, DALL-E 2 is strictly a research project at this stage. Microsoft's decision to withhold DALL-E 2 from public and commercial use is a responsible move. It allows the company to further refine the technology and develop safeguards to reduce potential abuses before considering a broader release. Microsoft's primary focus of DALL-E 2 is to explore the boundaries of text-to-speech synthesis and to understand its potential applications and implications. In controlled and secure environments, it could revolutionize fields like accessibility, content creation, and customer service. For individuals with speech impairments, DALL-E 2 could provide personalized and natural-sounding voice assistance. In the entertainment industry, it could be used to create unique voiceovers for characters in movies and video games, enhancing the immersive experience for audiences. Journalists and content creators could leverage DALL-E 2 to produce self-authored audio content, expanding the reach and accessibility of their work. In customer service, it could improve the interaction quality and user experience by providing more natural and responsive virtual assistants. Additionally, Microsoft has provided a mechanism for individuals to report abuse. If anyone suspects that DALL-E 2 is being used in a manner that is abusive, illegal, or infringes on their rights or the rights of others, they can report it through the Report Abuse portal. This system is designed to help monitor and control the use of DALL-E 2, ensuring that it is used responsibly and ethically. If you have made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.